Hi guys, and welcome to the next video. Today I want to talk about the next topic which actually came up to me by your comments because somebody had an OVC alarm, so I want to talk about a collision guard today. I know there is a video of the DCS that I was supposed to make, and that's coming. It's just hard to squeeze all of that information into a short video, so I'm trying still to think how to make it, but that's coming. Today though, collision guard. So something that's going to save you from damaging the robot or save the robot from damaging the equipment, but mostly the first part, so it's to do not damage the robot. Okay, so what is the collision guard or collision detect function on the FANUC robots? So we use it to fix two things, or to prevent from two things to happen. One is that we don't damage the robot by jogging it, and the second one is to prevent it from crashing when running the program. Or it won't prevent it from crashing, but it will prevent from damaging other things that are there, because the robot will stop when it knows. What does it mean, guys? Why do we use it? So imagine that like sometimes when we touch a hot surface with our hand, there is a sensors, right, that sense that the surface is too hot for us and we're hurting ourselves, and we're going to take that hand back. Or let's say we're, I don't know, trying to lift something, or something is squeezing our finger, and we have like that pain limit when we say, okay, that's it. So that's how the collision detect works. So basically, if the robot is crashing into something, if it's putting too much force in order to move further, that means something is not okay, and he will stop. Why is it crucial to set it correctly? It's because if the collision guard is set correctly, then we won't damage the robot, and probably will do little damage to a tool or the equipment on the station, because we will stop before the damage is going to occur. Of course, that's only theory. If the robot is running at full speed and we slam something, it will stop after, sooner or later, but it's just how much we're going to damage before that, basically. But it will help you when you're jogging and you don't see something and the robot starts to crash into something, then probably you won't do any damage. Without the collision detect option, you will just keep moving the robot until you will get an OVC alarm, and that's basically when you gather cycle power the robot. Okay, let's go back to the topic. So the collision detect function will work only correctly if you set your payload correctly. So please watch the payload video to make sure that your payload is set correctly. If the payload is not set, or it's not set correctly, your collision guard function will not work like it should. Because in the payload we have the necessary information for the robot in order for it to make a calculation to stop the robot when it's crashing into something. So very important, guys, payload before adjusting the collision. So when a collision can occur? So the collision can occur when the robot just slams into something. So you made a mistake, or something happened, something miraculously showed in the way of the robot, the ladder, that happened to me a few times, and you just smash it. If you don't have the collision guard function enabled, the robot will keep on going until it sees an OVC alarm, which is an overcurrent alarm, and that basically means he put as much current as he could to the motor, but he cannot move any further. If we had the collision detect option on, which is the collision guard, then it will slam into the ladder, but it will stop, because he will see that, oh, well, I was supposed to move nice and smoothly through it, the currents on the motor should be this and that, but suddenly they jumped, so I stopped. And that's why you need it. So basically you won't damage the robot itself. Now, can the collision detect function occur if there is no collision? Yes, it can. There are actually quite a few points where it can occur. So sometimes you might see a collision detect and you will go inside the station, look, and like, well, there is no collision in there, what happened? So when the collision detect can trigger if there is no collision. Point number one, what I've said, if your payload is not set correctly. Because the robot will think he's carrying something, but he doesn't carry anything, so he's expecting on each of the motors to see some value of a current, but he doesn't see it, or if you set the payload wrong, then it will expect to he's thinking that he's carrying a lot, but he's not, so he's trying to use a lot of current in order to move. So that's when the collision guard function is able to trigger without the collision occurring physically on the robot. The second option is where you have a path like going back and forward. So if you have a motion, for example, on axis 1, that will go like this, that's your first point, that's your second point, and then you go back to the first point. So robot is trying to do this movement. Then the problem that it will have before it can slow down has to accelerate the other way, so that can throw him out of the course, and that can cause the collision. So remember, like that motion, so basically going forward and backward, it's not good. Of course it's doable, you just need to do it the smart way, but that can trigger a collision. What else? Linear motions. So if you have a linear motion, again, see the video if you don't know what the linear motion is. And if they are close to a singularity, so that's where the robot has a lot of solutions how to move. It will try to speed the axis very fast, and that again can trigger a collision detect. The next option, the ACC that I talked about was in a previous video. If the ACC value is specified, and you can make it 150 for example, so that's higher than normal, so he'll try to move very fast, very aggressive. Then when the collision collision detect can occur without the collision, because the robot will try to move very fast, but it has a lot of load on it. There is a lot of tension on all of the gears and stuff, and then a very high current, boom, collision detect. Well, there is no collision, but the collision detect occurred. Then jerky motions. So if your program is like kind of like a robot, but just stopping and making funny movements, then again that's how the collision can occur, because the robot has to like decelerate, accelerate, decelerate, accelerate, so like stop and go, stop and go. Again, that can cause an issue with the collision detect. You got to revise your program, maybe change the fine or CNT0 to a CNT10, try to smoothen up the robot path, then you should not have the problem with the collision detect. So those are the main problems that I've seen personally when the collision detect was triggered, but there was no collision. So I hope that helps sometimes with troubleshooting, because I know it happened to me as well, that the robot will show where there is a collision, but there is not like physical collision on the robot. Well, maybe that's why. Check your programs, see what's going on, maybe you can find a solution over there. What can we do with the collision detect? We can do also cool things that I'm not going to talk about. I will just mention, so just so you know it's possible. You can do a collision skip. So there are like force sensing applications where you will try to detect the part, like the edge. So you can add a force sensor to it, to the robot on the axis 6, and then it works kind of like a CMM measurement that the robot will go and try to touch few things, and if he detects the collision, then he will stop and go to the next motion. What's important about the collision detect, and I didn't say, it has like, I would say, kind of a safe option. So remember, like I told you, that when you touch a hot surface, you take your hand back. The collision detect and collision guard works the same. So whenever the robot will hit something, he will try to move back the axis. So he will have 200 milliseconds to do it. So if he crashes into something, and there is the option of like releasing the axis, so it can actually go back from the collision, he'll try to do it. It might not be possible, but there is this brief moment where he's trying to go back to release the collision so it doesn't push so hard. But what happens when it hits really hard, guys? So you go very fast, and then suddenly something is on the way and you will just slam into it at the full speed. You might have an OVC alarm, and that's an overcurrent alarm, And what that means basically is that the current of the motor is so high that even though there was a collision detect, it of course it will trigger the collision, but you will get the OVC alarm as well. So the collision guard, and when you see a collision detection on the HMI, on the Robotics pendant, you just hit the fault reset. Usually it will clear and you can jog the robot back. With the OVC alarm, that's not possible. You need to cycle power the robot before moving any further. That's the difference between the OVC alarm and the collision detect. Sometimes it happened to me quite often when the robot hits very hard. You will be stuck on a collision detect function and you won't be able to move, because it will just, every time you try to push the dead man, hit the reset button and try to move, it will just trigger the collision detect one more time. What can you do then? You will go to the collision guard option and turn it off or lower the value over there that we're going to do on the exercises, and by then you're turning off the collision detect and you can move the robot back. But you need to know which way to jog to do not destroy the robot more, because as soon as you turn it off you can also crash it more instead of taking it out of the collision. And that's why I made the other videos about the frames, so you know where to jog the robot when you crash it. So you have your right hand rule and then you know your X, Y, Z, and you can drive it out safely out of the collision without causing any problems. Do remember to turn the collision detect back on, because usually it will not turn on any of the programs automatically. At least I've never programmed it with it turning back off and on, except when I was using a soft float option. That's a different topic. So always after you disable it, when you are driving out of the collision, enable it back, and your robot will be good to go. Okay guys, let's finish the talking now and let's get to the exercises. Hi guys and welcome to the exercises. Okay, so let's talk about the collision detect. So in order to get to the collision detect menu, we're going to do menu, then we'll go to the setup, and there is a collision guard option right here. Let's click on it. What do we have in here? So basically, as you can see, there are 5 things that we can change. So the first one is the option if the collision guard is enabled or disabled. Then the next thing is the robot sensitivity. So we can change that from 1 all the way to 200, which is the maximum value. So the lower the sensitivity, the robot will ignore, the robot will care less about the collision. So the lower the value, the more damage will be done. The higher the value, the less damage will be done. The next one is the register for setting the sensitivity. So basically in here you can specify a register, let's say 100. And now when we're going to use a collision adjust function that I will show in a second, we're going to use register 100 to override this value. So whatever we're going to specify in here, as soon as we're going to do collision guard adjust, we'll override it with the value in register 100. I will show that on the program. The next thing is the collision guard error, and that's an output that you can set when the collision will occur. So we can send the input to the output to the PLC with a specific number. In my case it's 198. So whenever the collision will occur on the robot, you're going to set so whenever in here the red error with collision detect shows, you're going to send an error to the PLC, like you'll turn this bit on, hey, there's a collision. And the last one is the collision guard enabled. So basically that's an output to PLC saying when the collision guard is enabled or disabled. So those are the options that you can change. Now I wanted to talk a little bit more about the sensitivity. So when you get to a new robot, usually the best option is to start at around probably 150, maybe 140. So you're going to program all of your motions, and then I highly recommend to put the sensitivity to 150, accept it, and run all of the programs at the full speed. If the robot is not failing while running with that sensitivity, you leave it like this. If the robot is running but it's stopping on a collision, you go down by 10%. So you will do 140, and you're going to try to run all of the programs again. If the robot doesn't fail, that's good. You can keep that value. It's a safe value for the robot. Then you're sure that if the robot is going to hit something, probably not too much damage will be done. Again, if it's failing, go down to 130, and so on and so on. I highly recommend not going below 100, because then the robot is less sensitive. Sensitive. So I kind of think if you need to go below 100, maybe there is a problem with your payload, maybe there is a problem with your programs, maybe there is a problem with the ACC. Take a look, investigate, and try to get that value as high as possible. Just so you know, I ran some robots on 80% because they were just having too much stuff on it and nobody accounted for that. But normally, the higher, the better. Okay, so let's go back to our programs. So I'm going to use our regular table, so that one, as our reference. So let's go in. And what do we have in here? So that's our old program. Remember the one that moves around the table. And what we can do, we can add the collision guard on, off, and adjust the value. So we're going to do instruction, then we're going to go to the next one, and one more, and there is a collision detect in here. When you open that instruction, there are three things we can do. We can turn the collision detection on, off, and we can do the collision adjust. So let's say we want to turn off our collision detection for the first motion for some reason. Then after the first motion, we want to enable it back. So we're going to go again to collision. We're going to turn it back on. And we want to run. And at this point, we know that there is a change. Maybe the robot is going into some tight space. Or maybe we know that that's a kind of a risky motion because something can change and we want to prevent or we want to detect the collision earlier. So we're going to do the collision adjust in here. So first thing, we're going to set our register 100 to a value. So that's going to be 150 for me. So now let's go back very quick to the collision guard. As you remember, I use register 100 to set the sensitivity. So right now I'll adjust it to 150. Putting just a register is not adjusting the value. We need to use the collision guard adjust and then we will adjust the value. So we're going to go to, again, collision detect, collision guard adjust. There you go. So now we're going to adjust the collision value to our register value. And after that motion, we want to put it back to our 100. So what we're going to do is basically I'm going to copy those lines, paste it at the end of the program, and I want my collision guard to be 100 in the end. And there you go. That's our program with the collision detect on, off, adjusting. So let's do two screens. I'm going to show you the IOs. So the one that I had set are 198 and 194, where one is collision guard enabled, the other one is collision guard error. So if we crash into something, then we're going to see the error. So right now, when we're going to run that program, you can watch that one. I think I did it a little bit too fast, so let's move in step. So as you can see, when we turn detection off, the output for the PLC turned off, and as soon as we pass the first motion, we pass the command, we're turning the collision guard back to on, and we continue with our program. We're doing the collision guard adjust to a value of 150, and then we're running with the higher collision right now. And at the end, we're going to set it back to 100, and that's done. So that's all, guys, you can do with the collision detect. Remember always to set it in here. Remember to use it. Remember to keep it on, because it will save your tool, it will save your robot from getting damaged. There are a few things that I forgot to tell you. So let me demonstrate maybe that on the robot. So before we're going to get a collision detect, we're going to get a servo 53, which is a disturbance access. And what does it mean? It will tell you also what axis is it. So what does it do basically? It's saying, hey, I am almost at my limits. I'm going to trigger a collision soon because the currents that I'm reading on the axis are very high right now. So basically, usually if the robot will run and you will start seeing disturbance access, that means, well, something is not going okay and you're about to crash, or maybe your motions are not smooth enough and the robot is getting wrong, too high values on the motors. So that's the error. So first you're going to see the disturbance access before the collision occurs. Usually when the collision occurs, you're going to see the collision detection, so basically that the robot collided with something. And the last error you're going to see if you hit too hard, and so basically the collision guard worked but it didn't stop the robot fast enough, or the movement was so high, you're going to get the OVC alarm, and that alarm means an overcurrent alarm, and that means you hit it so hard that the collision didn't work and the robot is putting so much effort, or put so much effort to get there with like the basically hit, and the axis, the current of the axis went so high that right now you're in trouble. The only way to get rid of the OVC alarm is, like I said before, is to cycle power the robot and then jog it out. That's pretty much all what I wanted to show you, because there are other options, like I said, the auto collision recovery and collision skip. Those are the other topics we can talk about, but maybe later. That's it for now. Okay guys, I hope you enjoyed the video. I wish you 0 crashes and I wish you a great time. Don't forget to like, subscribe. What can I say? See you in the next video. Bye bye.